this lesson, we will take a look at the way we can organize sets visually using Venn diagrams. This is particularly useful when we have 2 or 3 sets we are working with. Take a look at the following 2 sets. Here I'm going to use circles to show which groups of numbers are which set. Would you be able to describe these 2 sets using words? Let's call our first set A. A is the set of the first 5 whole numbers. Our second set, let's call it B. B is the set of the first 4 prime numbers. Do you notice anything about these 2 sets? Can you see how the 2 sets share some elements? Which do they share? In this case, it's possible for us to simplify our picture in the following way. When sets share elements, we may overlap the circles to show this. Which elements are in A and B? Which elements are in A or B? 3, 2, and 5 are in A and B. This is the overlapping region. And all of our numbers, 1, 4, 3, 2, 5, and 7, are in A or B. This slide gives a quick summary of the regions of interest when we use the phrase A and B, and when we use the phrase A or B. In a Venn diagram, we will always use A and B to refer to the shared elements, and A or B to refer to all elements. Next, let's define 2 sets. A will be the set of objects on this slide that have a right angle, and B will be the set of objects on this slide that are triangles. Take a moment to think about where our 4 objects are going to go in our Venn diagram. First, our isosceles triangle doesn't have a right angle, so we can simply slide it over into the far right of our diagram. The parallelogram isn't a triangle, so we can't put it on the far right. It also doesn't have a right angle, so we can't put it in the other circle either. So we're forced to let it sit outside of the diagram, uninvited to the party. Next up, the rectangle does have a right angle, so we can slide it to the far left. It's not going to go in the middle since it's not a triangle. Finally, we can slide our last triangle into the far right, but we may notice that it's a right triangle, so it's actually best placed in the overlapping region. What's different about this example compared to our last one? Well, this example shows us that not all objects have to be placed into the Venn diagram. There may be elements that have to be placed on the outside. For now, be mindful of this. We're going to give these objects a name a bit later in this section. What if we changed set A to be the set of 4-sided shapes? Take a moment to try to sort the objects one more time. Again, we can go through each element one by one and place it in the appropriate section of our Venn diagram. In this case, we might notice something when we're finished. Just because our original Venn diagram made it look like there was going to be an overlapping region, that doesn't mean that there will be any objects that are going to be in the middle. In this case, our 2 sets A and B are called disjoint, and we could draw the circles without the overlap. Sometimes we can use Venn diagrams to keep track of the number of objects in each section of the picture. Take a moment to pause the video and read the question before moving on. So how do we tackle this question? First, I might start by labeling the circles. Let's use H for hockey and F for football. Next, let's get at the wording and the numbers. 95 goes with H or F, so this actually refers to all 3 sections of our picture. Since we don't have any other numbers in here, that's not going to be super helpful right yet. 60 refers to H and F. That's the middle portion of our Venn diagram. Since it's only one shaded in region, we can fill this number in as 60. Finally, 15 refers to only F. This is the far right portion of our Venn diagram. Again, this is only one shaded in region, so we should be able to fill that number in without any worries. We can now go back to the number 95. Remember that it referred to all three portions of our picture. So if I want to figure out how much goes in this remaining portion, I could use 95, take away 60, take away 15, and that's equal to 20. We're going to fill that number in on the far left. Finally, you may notice that there were 100 individuals to begin with. So this means that 5 didn't take their kids to hockey or football. This number can go on the outside of our Venn diagram. To answer our original question, how many parents took their kids to hockey, we can look at the full H circle. Since both of these regions refer to kids going to hockey, we can add up 20 and 60 to get that 80 parents took their kids to hockey. Let's go back to our original number sets and try to figure out what happens if we add a third set into the mix. Recall that A was the set of the first 5 whole numbers, and B was the set of the first 4 prime numbers. Looking at our third set, how could we describe that one in words? Let's call this one C. Notice that C is the set of the first 4 even numbers. Now let's take a look at just A and C. What numbers do they share? Can you see how we might visually combine these sets to have an overlapping region? Notice that the numbers 2 and 4 are shared, so we could place them in the overlapping region of A and C. Next, how might we bring B into this combined picture? Well, note that 7 is not shared amongst any of the other sets, so we're going to place that in the outermost region. 5 and 3 are shared with set A, so they should be in the overlapping region, but they have to be above because they're not shared with C. And finally, 2 is shared among all of the sets, so it actually belongs in the middlemost region like this. Take a moment to go back to the 3 original sets and make sure we haven't lost an element along the way. If we have, let me know down in the comments. For 3 sets, the pictures A and B, and A or B are the same. They just look more complicated due to that extra third circle. And this is because A and B, as well as A or B, might contain elements that are also part of that third set, C. How might we tackle a problem involving 3 sets? Take a moment to pause the video and read the question. First, let's label our sets. Let's say M is for mathematics, H is for history, and PE is for phys ed, or physical education. Now, looking at the bullets, we can't put 32, 22, or 34 into the circles quite yet. For example, 32 actually refers to all 4 of the shaded regions here, the mathematics circle. So we're going to skip these numbers for now and work down towards the bottom. Notice that at the bottom, 3 refers to our very middle section. So I'm going to put that 3 in, as it represents all 3 subjects. Now that we have the 3 in the middle, we can look for statements with the word and. For example, if I shade in these 2 regions here, these 2 regions represent mathematics and history. Hey, I see that right here. That total should be 15. So taking 3 away from 15, we see that the number 12 should go in this region here. This region over here is history and phys ed. I know that 7 should be the combined total of these two regions. So taking 3 away from 7, I know that 4 should go in this missing region. And finally, math and phys ed should be equal to 10, but there's 3 in here already, so this region down here should be 7. Okay, so far we've used these 4 bullets. So now we can try to go back and look at the original 3. We know that 32 students enjoy mathematics, and that's going to be the combined total of these 4 regions. So how do we use the number 32? Well, we'll have to do a quick mental calculation. We'll have to do 32, take away 12, take away 3, take away 7. So that means there should be 10 here in this remaining portion. Okay, let's do the same thing for our history circle. These 4 regions must add up to 22. So we're going to do a little bit of mental arithmetic. We'll take our 22, subtract 12, subtract 3, and subtract 4. This is really 22 take away 19. So that means there should be 3 remaining here in that uppermost part of our history circle. And finally, we do a little bit of mental arithmetic for phys ed. Starting with 34, we have to take away 7, and 3, and 4. So that is 34 subtract 14. So that tells me that there's 20 that's remaining here in this leftover portion of our phys ed circle. Have we accounted for all of our students? Well, tallying up, we have 20, 30, 40, 52, 56, 59. So we're missing 1 student, so I'm going to put that last remaining student on the outside. That student doesn't enjoy any of the 3 subjects. All right, my little epsilons, stay positive.